Welcome back for part two, where we're going to explain properties of sound. So before we go into some deep explanations, we're going to discuss some properties of sound vocabulary. So sound waves are longitudinal or compression waves, as you can see to the right of the screen. Compression waves have two main parts, which are the compressions, where the wave is squeezed together, and then you have rarefactions where the wave is spread out or there's an area of low pressure. The wavelength is the distance from one point of the compression wave to the same point of the next part of the wave. Compression waves are also called mechanical waves. Sound is a type of energy. So let's look at our videos from part one. First, we had the Tacoma Narrows Bridge video. In this video, we watched a bridge swing back and forth and then collapse. And what basically happened is that the wind caused the bridge to swing back and forth at its natural frequency, which is called resonance. This swinging became amplified or stronger. And it occurred for so long that the bridge couldn't withstand the movement and collapsed. Resonance is also how musical instruments work and create the specific sounds depending on which buttons are pushed or which holes are covered, such as with the flute. Video 2, I'm going to play it for you real quick as a reminder. Video 2 demonstrates the energy that is involved in sound and how it can affect objects around it. The bristles move faster or slower depending on how they're reacting to the different wavelengths of sound. Changing the wavelength changes the frequency and pitch of a sound. Short waves produce high-pitched sounds, and long waves produce low-pitched sounds. Video 3 was paint dancing on a speaker. And this is another example of how the energy of sound can move objects, such as the liquid of the paint. The paint doesn't actually leave. The energy is moving the paint up and down depending on the beat and the tempo of the music. Video 4, which I'm going to play for you briefly. Video 4 demonstrates how the basically sound depends on the thickness or the type of medium. So the rock skipped at different areas of the frozen lake, and this led to a variety of sounds. So the different sounds are produced by the different thicknesses of the ice and also particles in the ice that can absorb some of the sounds. So today, part two's activities include a Nearpod, the longitudinal waves Nearpod, which I will show you briefly. All right, so this Nearpod is on longitudinal waves. It has 28 slides. And with this, you will do a couple of polls. You will look at some notes and some discussions. There's some open-ended questions, some definitions, some mini quizzes that you can type in. and just a lot of great information about sound. You can go to nearpod.com and use the code MAOQL. Also included in this part 2 is an optional extra Nearpod if you would like to go deeper and learn more. And let's go through it real quick. So with this Nearpod, there are 38 slides. That's all part of why it's optional, where it talks a little more deeply about pitch and resonance and vibrations. So you can take your time. You can do this one at any time. So to view this Nearpod, you can go to nearpod.com and use the code AFRDG. So for part 3, you will use a sound wave simulator to answer some questions. This is how the sound wave simulator looks. So what you're going to do is click graph, click play tone, and click waves. And what I would like for you to do is click the green button to start the tone. And you're going to move the frequency button first to see how that affects the wave. And then you're going to move the amplitude button to see how that affects the wave. And then I would like for you to do this with the particles. And then I would like for you to click a particle or look at a particle and then move the frequency button and stare at that particle. So you can see what is happening with the sound and what happens to matter or the particles as sound is transmitted. The second part of part 3 is a sound waves quizzes to evaluate what you have learned. Enjoy the rest of the week and see you next time.